today we're going to talk about negative exponents. And so by definition, what you're going to do with a negative exponent is you're basically going to move its place on the fraction bar. So in other words, if you have a negative exponent in a numerator spot, like a to the negative 2 power, which is kind of like over 1, then how you're going to solve that is you're going to move it to the denominator spot and make the exponent positive. So the only thing that'll change by changing its location is the exponent becomes positive. So if you have something like, x to the negative 3 power, that's equivalent to 1 over x to the positive 3 power. If you have 2 to the negative 2 power, that's equivalent to 1 over 2 to the positive 2 power. And so if the negative is in the denominator spot, like it is here, then you're going to move the number to the numerator spot and the negative n becomes positive n. So again, if you have 1 over a to the negative 3 power, then you're going to move it up and it's going to be a to the third. Now, if you have, obviously, if the denominator is 1, it's just a to the third, okay? So if you have something like 2 over x to the negative 7 power, that's going to be 2 to the x to the positive 7 power, because again, this is going to move up on the bar because that's what you do with negative exponents. And so that's the first main topic of this section. The second topic of this section is what happens when you're dividing with the same base. And so what we learn here is you have a to the m over a to the n, and what you can do is subtract these exponents. So a to the m minus 10. So remember, when you're multiplying, you add your exponents. When you're dividing, you subtract them. And so that just ends up being your answer. So again, if you do a to the 5th over a to the 3rd, then it's a to the 5 minus 3, which is a to the 2nd. If, let's say, you have it reversed, a to the 3rd over a to the 5th, that's a to the 3 minus 5, which is a to the negative 2, and we don't consider a negative exponent as a simplified exponent or a simplified number, and so we have to make the exponent positive, which we just learned in the other up here, that we just move it to the denominator spot and it becomes 1 over a squared. Now, one of the things that I personally don't like to do is I don't really like to subtract my variables when I'm doing division. What I like to do is I like to think about it mathematically. Like if I have 5 a's here at the top and I have 3 a's at the bottom, notice that when I do that, I'm going to be left with 2 a's at the top, or a squared. That's 5 minus 3 is 2, so a squared. If I have it this way here, right, I've got 3 a's up top, I've got 5 a's in the bottom, and notice that when I cancel the common a's, I'm left with 2 a's at the bottom, or 1 over a squared, which again, if I do 3 minus 5, I get negative 2, and it transfers down. So what I ask myself is, once all my exponents are positive, right, notice this is positive 5, positive 3, positive 3, positive 5, I ask myself, okay, where do I have more a's? Okay, I have more at the top. How many more? 2. And so a squared is my answer. In this one, where do I have more a's? I have more a's on the bottom. How many more? 2. So it's 1 over a squared, or 1 over 2 a's at the bottom, right? A times a. So that's kind of the way I look at it. So let's do a bunch of problems and let's see how we do with this, right? So we have 4 to the negative 2 power, which is equivalent to 1 over 4 to the positive 2, which is 1 over 16. If I have x to the negative 3 power, that's equivalent to 1 over x cubed. So again, if the negative's up top, you just move it to the bottom. In this one here, notice that I have 2x to the negative 4. Well, the 2 is raised to the first power, so guess what? The 2 is going to stay in the numerator spot, and the x to the negative 4 is going to move down and become 2 over x to the 4th power. So now we come to a fraction raised to a negative 3 power, and you have some options here. I'll tell you my favorite method, and then we'll kind of go over the different ways. But one of the rules that you can do is when you have a fraction raised to a negative power, you could flip the fraction and then the negative power becomes a positive power. And so you flip the fraction, nothing in the fraction changes, you just flip it, but the exponent becomes positive, and now you have 5 to the third power over 2 to the third power, which is 125 over 8, and that's the answer. Now, what if I didn't do that, right? Well, if I did it a little bit longer way, I think, I could have just distributed this negative 3 power to the 2, so 2 to the negative 3, and I could have done the same thing with the 5. That would have been 5 to the negative 3. And since 2 to the negative 3, the exponent is negative, it would go down to the bottom. And because the exponent is negative at the bottom, I'd have to move it to the top. And again, this would give me 125 over 8. Again, same thing, except I feel like it was a little bit easier the other way. Now, you might say, how do you know that this works? Well, let me kind of show you the short of it. We don't want you to have to do it the long way every time. Obviously, we want you to learn the shortcuts. However, you do want to understand why it is how it is. So in a problem like this one, 2 over 5 to the negative 3 power, remember that this is the same as 1 over 2/5 to the third power, because we've already done that, right? By definition, to make this positive power, you have to put it in the denominator spot. Well, notice that a fraction is the same as a division. So it's 1 divided by 2/5 to the third power. And I can even simplify 2/5 to the third power, I know is 8 over 125. Well, remember that division is stay, change, flip. And notice that when I do the math, I end up with 125 over 8, which is the correct answer that we got before. But we don't want you to have to divide by something and then do stay and change and flip and all that. We just want you to apply the shortcut rules to it. So we'll do more, but we'll keep applying the rules. So here, notice that you've got negative 4 raised to the negative 2 power. The entire negative 4 group is being raised to the negative 2 power. So the entire negative 4 group is going to go down, and the exponent is going to go from negative 2 to positive 2. So it's 1 over negative 4 squared, which is 16. Notice something really important. When I moved this to the denominator spot, notice that the 2 went from negative to positive, but the negative 4, this coefficient or this number, did not change. And I want you to remember that, because that's really important. When we go to number 6, notice it's a little different. Notice that the negative 4 is not being raised to the negative 2 power. Really, only the 4 is. The negative is just kind of still there. So we make it negative 1, and then 4 to the negative 2 power is the same as 4 squared. So negative 1 over 16. And that's how you get that answer. Okay, some of you guys like to see this as negative 1 times 4 to the negative 2 power, which means negative 1 over 4 squared, or negative 1 over 16. And that works as well. So here we're going to just keep going. When they say simplify, what they mean is obviously get rid of any like terms that you can, simplify any fractions that you can, simplify your variables, and simplifying variables means positive exponents. So in this problem, x is to the first power, which is positive, so it stays at the top, and y goes to the bottom and gets a positive power. In number 8, sometimes what I do is I simplify the numbers first. 4 goes into 4 once, it goes into 16 4 times. So I've got 1/4. And then notice I have x to the third here and x to the fourth here. Again, I could do 3 minus 4, and I get x to the negative 1, which is 1 over x. Or I could have just realized that I have 3 x's up top, 4 x's on the bottom. Where do I have more on the bottom? How many more? 1. And so I know it's just going to be 1 over 4x. When I come to 9, I'm going to look at it, and I'm going to just move things on the bar, right? 4 is to the first power, so it stays at the top. X is to the negative 3 power, so I'm going to move it down. Y is to the positive 2 power, so it stays up. And Z is to the negative 4 power, and so it goes down. And so this is the answer, 4y squared over x cubed, z to the 4th. And when I come over here to number 10, I kind of do the same strategy, right? So I know 3 is to the first power, so 3 is going to stay at the top. X to the negative 2 is negative power, so it's going to go down. I'm going to do the y to the 4th stays up. And then I go to the denominator, I do the same thing. I have an x to the 4th, so that's going to stay because the 4 is positive. And I have a negative 3, which is going to go up because it's negative, right? And so now I can just simplify the numerator and the denominator spots. I've got 3 y to the 4th, because this is all multiplication, right? They're timesing each other. So 3 times y to the 4th times y to the 3rd is 3 times y to the 7th. And then this will be x to the 6th at the bottom. And that's my answer there. And again, we just keep simplifying, keep going through the process. Now this one here is 5 to the 9th power over 5 to the 7th power. So again, when the bases are the same, what you're doing is keeping the base and you're subtracting the exponent. So it's going to be 5 to the 2nd power or 25. And so we can't just simplify the 5 and the 5 because that doesn't work, okay? We have to take it as this repeated multiplication. And again, if I drew out 9 5s at the top and 7 5s at the bottom, you would recognize that you'd be left with 2 5s at the top when you cancel them all out. So the same kind of goes for 14, which is a similar one. Notice in 14, you've got 7 to the 5th power, and then the negative 3 over here, we can move that up and make it 7 to the 3rd power, and together, that's going to be 7 to the 8th power, or whatever that number ends up being. I'm not going to ask you to multiply that out without a calculator. And then when we go to variables, that's a little bit more straightforward. So again here, the long way is to think of it as x to the 14 minus 10, which is x to the 4th. The short way, the way I do it, is I look at it and I say, well, I've got 14 x's up top, I've got 10 x's at the bottom. Where do I have more? Well, I've got 4 more up top, so x to the 4th is my answer. On this one, notice I have, 4 extra x's on the bottom, so I know that it's going to be 1 over x to the 4th. Now, again, you can solve this, as x to the 10 minus 14, which is x to the negative 4, which converts to 1 over x to the 4. Either one, either method is going to give you the correct answer. In 15, again, I try to simplify my numbers when possible. So I know that 5 goes into 5 once and into 15 3 times. So I've got 3 here. My x to the negative 4 is going to go down and become positive. My x to the negative 8 is going to come up, and my 8 is going to become positive there. And again, now I have to figure out, I've got x to the 8 up top, x to the 4th at the bottom, so it's going to be 8 minus 4, or 4. Or again, I've got 4 more x's up top, so it's going to move to the numerator spot. Again, we try to get rid of our negative exponents first and foremost, right? So let me just do the numbers. I know 5 goes into 15 3 times, and 5 goes into 25 5 times. So I'm going to start by having the simplified fraction. Then I've got a to the negative 5, which is going to go down. I've got b to the negative 1, which means b is going to go down. I've got a to the negative 2, which means it's going to come up. And b to the 4 is going to stay down at the bottom because it's a positive exponent. So now when I go to simplify, I'm going to look at this and I see that I have an a squared up top, an a to the 5th at the bottom, which means I'm going to have 3 a's left over at the bottom. Or again, a to the 2 minus 5, which is a to the negative 3, which means a to the 3rd at the bottom. And then my b's, b to the 1, b to the 4 is going to equal b to the 5th at the bottom. So this ends up being 3 over 5 a cubed b to the 5th. And the last couple slides, this one is a little bit more challenging because this one's asking you here about, it has a fraction to a negative power. So again, I can do these 2 different ways. I'm going to show you both methods. The first method is going to require, to what we talked about, is I'm just going to take the entire fraction and I'm going to flip it as is. So I don't change any negatives within the fraction. I'm just taking the numerator, moving it to the denominator, denominator to the numerator exactly as it is, and I'm going to make it a positive 2 power. Okay? At this point, some people like to simplify the inside of the parentheses first. Others like to just take everything to the power. I kind of like to take everything to the power, which means it's going to be 4 squared, a to the negative 6 power, b to the 8 power, and my denominator is going to be negative 3 squared, a squared, and b squared. Now that I did this, I can kind of work with my numbers a little bit. I've got 4 squared is 16, negative 3 squared is 9. And I can kind of make all my exponents positive. I'm going to move the a to the negative 6 down, leave the a to the 2 down there, the b to the 8 stays there, and the b to the 2 stays there. So when I simplify, I've got 16b to the 8. I'm going to combine my a's here. And now I look and I'm like, okay, 16 and 9 cannot be simplified any further. The a is fine, but my b's can be a little bit simplified, right? I've got 8 b's up top, and I have 2 b's at the bottom, which means I'm going to have 6 at top. And so 9a to the 8, and that's my answer. So that is one way to do that. And again, I could have simplified here. I could have gotten rid of negative exponents in the first step. I could have done a lot of things. There's just many ways to do these, but that's the way I chose to do that one. Another way to do it is to basically distribute the negative exponent to everything and not really flip the fraction. It's not my favorite method, but it's, kind of similar. Now, what I would do prior to doing this is I would simplify within the parentheses if I can. And notice I have negative 3 over 9. Well, 3 goes into 3 once, and 3 goes into 9 3 times. I also have an x over an x, which just cancels out. So before I distribute this negative 3, I could clean it up to get to this. So my insides, notice it's just 3z negative 1 to the negative 3 power. So I just took the x's out and I simplified the numbers a little bit. Now I could either flip the fraction and make the negative 3 positive, or I could distribute that negative 3 exponent. And I'm going to distribute it to everything just to kind of show you how it would look using that method. Okay, so it's going to be negative 1 to the negative 3 power, like that. It's going to be y to the negative 2 times negative 3, or 6. It's going to be 3 to the negative 3 power. And it's going to be z to the negative 1 times negative 3, or cubed. And so now I look at this and I'm like, all right, my y to the 6th is going to stay there. My z cubed is going to stay down there. And now I know my negative 1 is going to go to the bottom to the 3rd power, and my 3 is going to move to the top and be raised to the 3rd power. So because these two exponents were negative, I kind of had to flip those. So now I've got 3 cubed is 27, and negative 1 cubed is negative 1z cubed. So this is your answer, or you could just do negative 27y to the 6 over z cubed, like that. These are the same thing, just a little bit different, but they're the same. And so that's it for these type of problems. So again, there's multiple strategies you can utilize, multiple methods. You could, again, with these, you could flip and convert this to positive. You could distribute to everything as it is, and then you could simplify after. Or you could simplify a little bit first, so you work like I did, so you work with some smaller numbers. So there's just a lot of ways you can go about solving these, and you have to find the way and method that works best for you.